Hi everyone, I'm Meghan Heckelman,
And I'm Jennifer Molia.
and today we're going to talk a little bit about free fall. First, we'll go into the basics,
And then we'll talk about the reference table and more specific concepts.
and then we'll move to some practice problems. The answers to the practice problems,
As you'll soon see,
will help you crack the lock to the escape room. Good luck! First, we'd like to introduce free fall. The meaning of free fall is exactly what it sounds like. An object with no initial velocity begins to fall and immediately starts to accelerate due to the natural pull of gravity. For example, Mr. Musumeci is sitting at his desk and all of a sudden drops his pen straight down. Think about it. Is free fall a scalar or a vector? If you think vector, you're correct. In the example scenario, the pen has a direction, down, and a magnitude, say 0.5 meters per second. For the sake of Regents physics, we're going to assume that there is no friction and therefore no air resistance to worry about. For problems that pertain to Earth, gravitational acceleration remains constant. This value is represented by g. Finally, you'll know you're dealing with a free fall question when it uses the words falls, drops, or falls freely.
Okay, before we go any further, we need to talk about the reference table, which, besides your brain, is your most powerful weapon when answering Regents questions. If you flip to the back cover, you'll see three formulas. First, we have Vf equals Vi plus At. Final velocity equals initial velocity plus acceleration times time. Then we have Vf squared equals Vi squared plus 2Ad. Final velocity squared equals initial velocity squared plus 2 times acceleration times the distance. Finally, we have d equals Vi plus 1/2 At squared, which means distance equals initial velocity plus half the acceleration times time squared. It is very important that with the second piece, you don't square everything. In the calculator, make sure just time is squared. When you are presented with a problem, you should pick the formula that will allow you to solve for the missing variable by using variables you already have. These variables include not only the ones given by the question, but 9.81, which is always going to be your acceleration.
The first type of freefall deals with objects that are dropped. Think back to the example of Mr. Musumeci dropping his pen on the ground. The critical value for this unit in all of the beginning units in Regents physics is 9.81 meters per second squared. This is the constant gravitational acceleration that we mentioned before. Though this is represented by g, an important thing to remember is that with the formulas, g and a are interchangeable. For your purposes, this means that whenever you see an a, you can go ahead and plug in 9.81 meters per second squared. It is also important to note that when an object is dropped, its initial velocity is 0. A lot of physics is common sense. Thinking back to the pen example, the pen's initial velocity is 0 because it isn't moving until it is dropped.
The other type of freefall occurs when an object is thrown up. It starts with a positive velocity, but no matter how fast it is going, it will slow down as soon as it leaves due to gravity acting on it. Just like when an object is dropped, the velocity will decrease at a rate of 9.81, that critical number that must be remembered as the Earth's standard acceleration. At the object's maximum height, velocity will be equal to 0 and the acceleration, as mentioned before, will be equal to 9.81 meters per second squared. As the object falls back down, its velocity becomes negative as well as becoming equivalent to the initial velocity from before when it was thrown up. The last thing you need to know is that the time it takes for the object to reach the maximum height is equal to half of the total flight time. These kinds of problems are a lot less popular than the questions about objects being dropped, but having an understanding of this concept will help you better comprehend the rest of the unit.
Oh no! You're an apprentice in Isaac Newton's physics lab, and the scientist has gone mad. You need to escape as fast as possible. There's a lock with 3 digits. Your job is to find them. On the next slides, there will be 3 problems, each with 4 answer choices. Once you do a problem, record the answer choice in your notebook. By the end, you'll have the 3 digits you need to unlock the door and escape the room. Remember to use the best, most appropriate formula for each problem. The scientist will know if you do not substitute with units. Practice question 1. An object with a mass of 4 kilograms is dropped from a height of 45 meters. How long does it take to hit the ground? Choice 1, 3 seconds. Choice 2, 3.03 seconds. Choice 3, 2 seconds. And choice 4, 4.9 seconds. Practice question 2. An object is dropped and has a final velocity of 53.2 meters per second. Find the time it takes for the object to fall. Choice 1, 5 seconds. Choice 2, 9.81 seconds. Choice 3, 53.2 seconds. And choice 4, 5.42 seconds. Finally, practice question 3. An object is dropped and is in the air a total of 9 seconds. How high is the object dropped from? Choice 1, 980 meters. Choice 2, 400 meters. Choice 3, 397 meters. And choice 4, 9.81 meters.
Okay, time to put your physics knowledge to the test and escape the mad scientist before it's too late. Write down the multiple choice number you chose for each question on your sheet of paper, and we'll put the code in the lock for you. Hurry up! Here's the correct code that releases you from the hectic physics lab and Newton himself. Did you make it out? Next, we'll explain each answer and how you should have gotten it so you can be sure you'll escape next time. For this first question, we chose this formula because we knew that we had the variables of the initial velocity, acceleration, and distance, and that we needed to find the time. The initial velocity when an object is dropped is always 0 meters per second. Earth's standard acceleration is always 9.81 meters per second squared, and the distance of 45 meters can be found in the problem. When we plug these numbers into the formula and an x for time, the value we need, we have our substituted formula. After solving, the answer that we get is 3.03 seconds. For the second question, once again, we chose the formula with the value we need to find, time, as well as the values we already had, final velocity, initial velocity, and acceleration. Similarly to the last question, we can plug in 0 meters per second for the initial velocity and 9.81 meters per second squared for the acceleration, getting the final velocity of 53.2 meters per second from the problem. Once we substitute these values into the equation, we can solve, getting a final answer of 5.42 seconds. For this last question, we conducted a similar process to the previous two, plugging in 0 meters per second and 9.81 meters per second squared for initial velocity and acceleration respectively, then getting 9 seconds for time from the problem. We found a formula with all of these values as well as the value we were solving for, distance, and plugged in the numbers. The answer we got was 397 meters.